To produce stable electrophysiological recordings from Drosophila larval neuromuscular junctions, first dissect open a larva to expose the body wall muscles and nervous system. Prior to recording, the axons at the base of the CNS are cut posterior to the ventral ganglion. Then a recording electrode is placed on the muscle of interest, and a stimulating electrode is placed near the innervating motor neurons. The severed axons of the motor neurons are sucked into the stimulating pipette. Excitatory junction potentials can then be recorded. To begin the experiment, dissect wandering third instar larvae to expose the body wall. This protocol is modified for electrophysiological experiments by using short dissection pins. These are about 2 to 4 millimeters in length and are less likely to hit the microscope objective and electrodes during the experiment. This procedure begins with placing a third instar larva on the dissection plate. Pins are placed in the posterior and anterior ends of the larva. Scissors are used to cut the larva open, and forceps are used to remove the internal organs. Finally, 4 more pins are placed in each corner of the larval body wall to hold it taut during fixation. In Drosophila larvae, there are 30 muscles per hemisegment whose arrangement within the peripheral body wall are known. A total of 35 motor neurons innervate these muscles in a highly stereotyped pattern. To access the neuromuscular junction, or NMJ, it is necessary to carefully dissect each larva. With proper dissection, the NMJ may be used for imaging, immunohistochemistry, or electrophysiology. Begin the procedure by putting a drop of HL 3.1 buffer onto a dissection plate. The buffer is made in advance and cooled on ice. Carefully pick a wandering third instar larva from the side of the vial using large SS forceps. The movement indicates that the larva has not entered pupation. Place the larva dorsal side up in the buffer drop on the dissection plate. The cold buffer will anesthetize the larva and keep it still. Using forceps, place a minutian pin between the posterior spiracles. Then place a second pin close to the dark mouthhooks so that the larva is stretched out and ready to splay open. Using spring scissors, make a small horizontal incision toward the posterior end of the larva. Insert one blade of the scissors into this incision and make a lengthwise cut toward the anterior end of the larva. Then make horizontal incisions at the anterior end of the larva to the left and to the right of the pin. To remove organs such as the gut, add several drops of HL 3.1 buffer to the animal. The gut and other organs will float up into the solution, and they can be pulled away from the body using forceps. Also remove the tracheal system with the other organs. Now expose the interior body muscles by pinning back the flaps made by the incisions. Be sure to stretch the body walls open horizontally and vertically when pinning down the flaps. Remove any remaining organ pieces and wash once by adding fresh HL 3.1 buffer. After exposing the body wall, use forceps to hold the CNS and raise it slightly. Then cut the peripheral nerve motor axons and remove the brain. After removing the brain, wash the dissected prep twice with HL 3.1 buffer with 1 millimolar calcium. Now that dissection is complete, intracellular recordings can be made from the larval muscle cells. Place the dissection plate on the electrophysiology microscope and submerge the prep with HL 3.1 buffer plus calcium. Then fix the bath electrode so it is in contact with the solution. The suction electrode is used to stimulate the peripheral nerves that innervate the muscle. Position the suction electrode in the dish first to avoid vibrations when the intracellular electrode is placed on the muscle. Once the electrode is in the dish, position it close to the motor neuron that innervates muscle 6 in the third abdominal segment. Apply gentle suction until the cut nerve is inside the glass pipette. Be careful not to stretch the nerves when suction is applied. Raise the pipette slightly so it is not touching the muscle, and then position it so it is not pulling on the cut nerve fibers. Once the suction electrode is in place, position the recording electrode for the intracellular recordings. Use a sharp microelectrode filled with 3 molar potassium chloride. Position the recording electrode above the center of muscle 6. Adjust the input offset so it reads 0 for the bath solution. Slowly lower the electrode and approach the muscle under high optical magnification until it touches the muscle surface. To confirm that the muscle has been penetrated, watch the oscilloscope. The resting membrane potential should be at least negative 60 millivolts. Sporadic miniature end plate potentials should now be visible. Once the recording electrode is in place, let the cell stabilize for 1 minute before starting the recordings. Use an Axon HS2A head stage and an AxoClamp 2B amplifier to detect changes in the membrane potential. The AxoClamp 2B is interfaced to a computer that runs pClamp software through the Digidata 1322A, which digitizes the signal. Record the membrane potential on a PC with ClampX software. Apply stimuli to the motor axon to generate excitatory membrane potentials, or EJPs. Once the EJPs are generated, record the miniature EJPs over a 3-minute period with no stimuli. To generate EJPs, use a master 8 pulse generator to stimulate the severed end of a motor neuron. Program the generator to deliver 0.3 millisecond square voltage pulses. Program a 5-second interval time between stimuli to allow synaptic recovery at the NMJ. Record at least 10 evoked potentials from each muscle and average the amplitudes. This figure shows a typical trace recorded from muscle 6 of a wild-type Drosophila larva with evoked EJP responses and spontaneous mini EJPs.
We've just shown you how to record synaptic potentials from the neuromuscular junction of Drosophila larva. When doing this procedure, it's important to remember to complete the dissection within 3 to 10 minutes and to start the electrophysiological recordings immediately while the cells are still healthy and responsive. If the dissection takes too long, the resting membrane potential of muscle cells will be less than minus 60 millivolts, which is too low to record. So that's it. Thanks for watching and good luck with your experiments.